Okay, in this video, we're going to be doing JEE Main 2022 online, 30th of June. It's a problem that is going to involve a Riemann sum and then partial fraction decomposition. A really good question, especially if you were in Calc BC. You would have to know all of these skills. If you're in AB, you need to be able to take this limit and turn it into a definite integral. So it applies to basically everybody. So it's the limit as n approaches infinity, the sum from r equals 1 to n of r over 2r squared minus 7rn plus 6n squared. All right, let's get down to this. So you look at this, the first thing that tips me off that this is a Riemann sum is this part. We're taking the limit as n approaches infinity of a summation. So if you've started to do a lot with series, you might be thinking, oh, this is like an infinite series type of problem. Not really. When you're taking the limit of the summation, you should first think, is this a Riemann sum? So if it's a Riemann sum, we need to be able to make it look the way we're used to. So I like to just write that down. Like I think of this as the limit as n approaches infinity. I tend to use I as my index. They're using R in this case, but I goes from 1 to n f of x sub I delta x. And in this context, delta x is going to be b minus a over n. So b and a, or a and b, are the bounds of the integral, where you're starting and where you're stopping. And then x sub I, or x sub r in the case of this problem, would be a plus I delta x. All right, so with that in mind, we got to take our summation, or summed, I guess, summed? I don't know, the thing inside the summation, and we need to make it look like f of x sub I times delta x. Key here is delta x. I see that everything, so r is the counter, and n is the upper bound, and if you look at our delta x, it's b minus a over n. I got to somehow get like a 1 over n or a 5 over n. I've got to get delta x. I look at what I have r over 2r squared minus 7rn plus 6n squared. I'm going to take n squared out of everything in the denominator because n is the number of rectangles that I'm using, and I feel like that'll get me on my way. So I'm going to start with that. So we'll have the summation. I'm taking n squared out of everything in the denominator. So I end up with 1 over n squared, and then I have r over 2r squared over n squared minus 7r over n plus 6, which still doesn't look exactly perfect because I don't want 1 over n squared for my delta x. I just want 1 over n. So I start to think, like, what can I do with this? Well, 1 over n squared is 1 over n times 1 over n. And the issue is in the numerator of this fraction, I just have r. I don't have r over n. So what I'm going to do is take 1 over n squared, make it 1 over n, and leave that as like a constant multiple type situation. I'm going to take the other 1 over n and move it into the numerator of my fraction, which will give me n goes to infinity, 1 to n, 1 over n, that's delta x. Now I have r over n. I have all over 2, the quantity r over n squared, minus 7, the quantity r over n plus 6. This is starting to really look like a Riemann sum at this point, where I've basically plugged in r over n for every x in the function. So now I want to start thinking, like, all right, how can I write my integral? Well, I've already said that I think that delta x is definitely 1 over n. I think that x sub r is r times 1 over n, or just r over n. Once I have that, I can find my bounds because I need to find x sub 0, which plug 0 in for r, you get 0. X sub n, plug n in for r, you get n over n, which is 1. And then our function is replace every r over n that you see with just an x. So our function f of x is going to be x over 2x squared minus 7x plus 6. Okay, so really what we're doing when we do this limit is we're doing the integral from 0 to 1 of x over 2x squared minus 7x plus 6 dx. So if you're in Calc AB, that would be where you would end on this problem. It'd probably be multiple choice and be like, which of the following is equivalent to this limit? So that's good. If you're in Calc BC or you're doing JEE Main, keep going. So I'm going to look at the next part of this and actually solve the integral. So our limit is equal to this integral. This integral is a kind of a classic partial fractions problem. You initially try to make u equal the denominator, but then you would need 4x minus 7. We don't have that. We only have an x. So let's factor the denominator. So 0 to 1, x over, we're going to go 2x, and then x. And then to factor it, we need to get positive 6 and negative 7 on the end. So I have negative 3 and negative 2. Okay, and then there's a dx. All right, so this is definitely a partial fractions problem, so I'm going to set that up. We have a over 2x minus 3 plus b over x minus 2, and that all of that is x over the quantity, 2x minus 3, x minus 2. I'm going to use the cover-up method to solve for a and for b. So to find a, I'm going to let x equal 3 halves. So if you're not familiar with the cover-up method, highly recommend it. I have a lot of videos on it. It's the best way to solve these problems. So if x is 3 halves, we go over to x, 2x minus 3, x minus 2, cover up 2x minus 3, and just plug in 3 halves. So the numerator is going to give us 3 halves. The denominator gives us 3 halves minus 2, which is negative 1 half. So a is negative 3. Then we do the same thing to find b. We let x equal 2. We cover up the x minus 2 in the denominator, plug in, we get b is 2 over 1, so just 2. All right, so we need to rewrite this. I'm going to rearrange it so that I have a positive thing minus a positive thing. So basically, I'm not going to say negative 3, 2x minus 3. I'm going to say 2 over x minus 2 minus 3 over 2x minus 3. So my integral becomes 0 to 1. We got 2 over x minus 2. I'm just doing that for my own convenience. It's like always a little bit easier to simplify if things are, the way you expect them. Like you don't usually expect to do a negative plus something. You expect to do a positive minus something. So I've rearranged it that way. All right, integrate these. These are just kind of your straightforward things. So for the second one, we need to make sure that there should have been a 2 in the numerator by the chain rule. So 2 in the numerator, 1 half on the outside. So we get 2 natural log absolute value of x minus 2 minus 3 halves. If I had to guess, I would say people who have successfully gotten to this point and are going to make a mistake would make a mistake right there. They would forget to put that 1 half in. So minus 3 halves, natural log absolute value, 2x minus 3. We're going from 0 to 1. The next step is just fundamental theorem we got to plug in. Fortunately, we get the natural log of 1 a couple of times. The natural log of 1, also, if you forgot absolute value on this problem, at this point, you're like, I don't know the natural log of negative 1. That should just signal to you forgot to put in the absolute value. Natural log of 1 is 0, so that whole expression that I just wrote is 0. Minus, we got to plug in 0, so we're going to get natural log of basically 2, minus 3 halves, the natural log of basically 3. All right, so now we have, I'm going to take out, because I'm trying to simplify this, I'm going to take out negative 1 half from everything, just get rid of that denominator there. So if I take out negative 1 half, I'm going to end up with a 4 here, 4 natural log of 2. So I didn't take out negative 1 half. I took out 1 half. There was already a negative in front. Sorry, I think I misspoke there. I'm not really sure if I did or not. Taking out 1 half is the same as dividing by 2. So in the case of 2 natural log of 2, it becomes 4 natural log of 2 when I take out 1 half. And then obviously minus 3 natural log of 3. When you have exponents, they can become coefficients. So negative 1 half, it'll be the natural log of 2 to the 4th, which is 16. Natural log of 3 cubed, which is 27. When you have subtraction between natural logs, that is division within the natural logs. We have negative 1 half, natural log of 16 over 27. The negative in front of 1 half is negative 1, and then coefficients can become exponents. So I'm going to make it 1 half natural log of 16 over 27 to the negative first, which just flips that over. So 1 half natural log of 27 over 16. So at this point, this was actually a multiple choice question, and I just forgot to put down the options. The reason I'm doing all this simplification is to match the answer choice. And now I need to take the square root. The square root of 27, I need to bring up the 1 half as an exponent. So it'll be the square root of 27 over 16. Square root of 27 is 3 root 3. Square root of 16 is 4. And there you go. This is a super good problem for all 3 of these tests. So Calc AB, you should have stopped a little while ago. Calc BC, you should have kept going. And JEE Main, you also should have kept going till the end. So nice Riemann sum partial fraction problem. I hope this was helpful, and good luck.